everyone, I'm in the lab today learning about the extreme conditions a rocket has to withstand in order to successfully leave the Earth's atmosphere. Things get pretty wild. Check this out. One of the biggest changes a rocket experiences after liftoff is air temperature. For each mile the rocket ascends, the temperature drops about 10 degrees until it exits the lower atmosphere. So I'm wondering, given that the temperature drops at most 125 degrees during launch, what is the minimum distance the rocket travels from the Earth's surface to the stratosphere? One of the engineers actually gave me an inequality to represent this change in air temperature. -10 times m is less than or equal to -125. In order to solve this problem, we'll be launching into solving inequalities. The good news is the process is super similar to solving equations, but with a few twists thrown in. Let's take a look. Yesterday, we learned that unlike equations, inequalities aren't the same when they're read in both directions. For example, 4 is less than 6 is not the same inequality when I swap the 6 and 4 to opposite sides. We also had to flip the symbol so that the inequality would stay true. I'm wondering whether this will affect how we use inverse operations when we're solving inequalities. Recall that I have to apply operations to both sides to keep the equation true or balanced. When I add 2 to both sides of the equation 4 equals 4, I end up with 6 equals 6, which is still true. Try that out with 4 is less than 6. Add 2 to both sides to see if the inequality remains true. When I add 2 to both sides, I get 6 is less than 8, which is still true. What about subtraction? Subtract 2 from both sides of 4 is less than 6 to see if the inequality stays true. Yes, that worked again. I got 2 is less than 4, which is still true. Okay, well, what about multiplying and dividing? Pause the video and multiply each side by 2, then divide each side by 2 and see if the inequality stays true. Wow! When I multiply and divide both sides of the inequality by 2, my inequality stayed true. I want to consider all the possibilities here. Pause the video and repeat each of the 4 operations: addition, subtraction, multiplication, and division using -2, and determine whether the inequality stays true. Well, that was interesting. Let's see if you ended up with the same results I did. When I add and subtract -2 to both sides, I still had a true inequality in the end. 2 is less than 4 and 6 is less than 8. But when I multiply and divide by -2, I wind up with -8 is less than -12, and -2 is less than -3. Are those inequalities true? No way! -8 is greater than -12, and -2 is greater than -3. So in order to keep inequalities true when multiplying or dividing by a negative number, we have to reverse the direction of the inequality symbol. Let's see how this works when I'm using inverse operations to solve an inequality. Consider the inequality 2x is greater than or equal to 12. Just like with equations, we want to isolate the variable, so what's happening to x? Right, we're multiplying by 2. How do we undo multiplication? Yep, we need to divide both sides by +2. Do I need to flip the inequality symbol? No, Dividing by a positive number doesn't require any changes to my inequality symbol. So, when I divide both sides by 2, I'm left with x is greater than or equal to 6. Unlike with an equation where I usually get one specific value that makes the equation true, when I solve an inequality, the solution is giving me a range of values that make this inequality true. Let's look at this solution on a number line. Choose a number on this section of the number line and substitute it for x. Do you end up with a true inequality? I chose 7, for example, and 14 is greater than or equal to 12. But what happens if I choose a value like 5? Well, 5 is not greater than or equal to 6, so it shouldn't be part of this solution, but let's try it just in case. 2 times 5 is 10. Is 10 greater than or equal to 12? No. So the values that make this inequality true are all values of x that are greater than or equal to 6. What about this inequality? Negative 3x is less than 15. What is happening to x? It's being multiplied by negative 3. Okay, so how do we undo that? We have to divide both sides by negative 3. I'll divide both sides by negative 3, and that gives me x is less than negative 5. If I put this on a number line, all of these values should make this inequality true, and all of these values over here should make this false. Let's try it out. Choose a value that is less than negative 5. I'll use negative 6. Negative 3 times negative 6 is positive 18. Uh-oh. Is 18 less than 15? Any ideas here? Oh, I know. Since we divided by a negative number to solve, let's try flipping this symbol and testing out a new value. When I flip the inequality symbol, my solution now reads x is greater than negative 5. Let's test a value here. I'll choose negative 3. Negative 3 times negative 3 is positive 9. Is 9 less than 15? Yes, it worked! So, when solving an inequality, if you multiply or divide by a negative number, flip the inequality symbol to keep the inequality true. Now you try. Solve these next two inequalities and graph each solution on the number line. Then, come back to check your work. First, I have x divided by negative 4 is greater than 12. To cancel this negative 4, I multiply both sides by negative 4. Since I'm multiplying by a negative, I flip my inequality symbol to keep this true, and I'm left with the solution x is less than negative 48, which looks like this on the number line. If I want to test my solution, I can pick a value like negative 50 and substitute it back into the original inequality. Negative 50 divided by negative 4 is positive 12.5. 12.5 is greater than 12, so my solution is correct. Next, I had the inequality x plus 5 is less than 1. Since I was adding 5 to x, I had to subtract 5 from both sides. That left me with x is less than negative 4. My number line looks like this. And just to make sure everything is correct, I chose a number, negative 5, to test my solution. Negative 5 plus 5 is 0, and 0 is less than 1, so my solution, x is less than negative 4, is correct. Let's see whether we can tackle this inequality and figure out just how far our rocket will travel to get into the stratosphere. Pause here and solve the inequality. Negative 10m is less than or equal to negative 125. To solve, I divided both sides by -10. Since I am dividing by a negative number, I flip the inequality symbol so that my answer reads m is greater than or equal to 12.5. That means I'm traveling at least 12.5 miles to get from Earth's surface to the stratosphere. I'm sure glad I'm not walking. Today, we started solving inequalities. Even though we're using the same inverse operations, we figured out pretty quickly that inequalities require special steps when multiplying or dividing by negative numbers. Make sure you finish these guided notes before moving on to the online practice. And remember, math is everywhere. Keep exploring.
Hey, hey.